In this video, we'll move into section 3.3, where we'll introduce more frequency tables discussion, but the bigger thing is that we'll introduce what we formally call a histogram. So everything in 3.3, we're again talking about numerical data, and what we're going to see is that a histogram is basically a special bar graph. It's a bar graph just like we saw with categorical data, but now we'll start to see a little bit more about how we lump our data sets together. So quickly want to show you something in the book, and then we'll do something similar on our own. What they do in the book, starting on page 97, but then continuing on 98, is they start talking about the number of partners for a queen bee. So we have 1 through 12 partners, and then the frequency that goes with it. And then they do the relative, and they even point out that with their decimals, they add up to 0.999. Doesn't exactly equal 1, but that's just simply due to rounding. So this is not a terrible chart. Again, 1 through 12, it's not bad. But if you just look a little further down, we start to see this ideal way of grouping it together. Instead of having 1 partners, 2 partners, 3 partners, let's lump them together. 1 through 3 partners, add their frequencies. 4 through 6, add the frequency. 7 through 9. So we're just tweaking the frequency table by, instead of looking at each answer individually, by lumping them together a little bit. So how do you then turn that into a histogram? What is a histogram? Well, now we're getting these bar charts over here, just the next page. And as you start looking at these bar charts, this first one over here, you have a bar for each number. But notice how it works with numbers. These bars now all touch. And notice this bar, it's halfway, it hovers to the left and to the right of 1, trying to make it clear this bar entirely represents 1. Similar with this bar, similar with this bar. Every one of these, an individual bar to go with an individual number. But the idea of a histogram is that now all these bars touch, so that we're truly treating this like the x-axis that it is. So instead of separate bars, the bars essentially run into each other. If you look at the very bottom of the page, sorry this doesn't come out quite as good, now you see we start lumping them all together. So now these bars are getting wider, and of course the frequencies are matching because now we're putting more people together, so to speak. But the bigger thing is now look at this bar. It starts before 1, and it goes halfway between 3 and 4 to make it clear this bar represents 1, 2, and 3. Similar with this bar. 4, 5, and 6 are all the numbers inside that bar, so that bar represents when a queen bee has 4, 5, or 6 partners. So I just wanted to give that explanation, to quickly say that, to quickly show you that in the book. So just to point out a few things. Again, they're still just bar graphs. We're still doing it in a very similar setup, but now all the numbers, again, treating the x-axis like an x-axis, all those x values have to be included. And then we just want the bars to touch. They talk a little bit more in the book, giving you a how to construct, but it's not that bad. So very, very similar to our bar graphs. Now, I will point out there are other textbooks I have seen, they go quite nuts about, setting up these intervals. They go really over the top about thinking about, what is the highest data value, what is the lowest. You decide how many classes there should be. So you want to divide that range equally. So again, if I use test scores, for example, if I had lowest test score of 60, highest test score of 90, and I wanted 5 classes, well, there's 30 units between 90 and 60. Divide that by 5 would mean each class should be 6 units wide. But notice I'm not writing that down. Our book doesn't care about that. The only thing our book really cares about is that you break your classes up evenly. So what I mean by that, and again, this will come up at the very end with some of the misuses, the number of bees problem, well, 1, 2, and 3 went together. 4, 5, and 6 went together. 7, 8, and 9 went together. Every time they're looking at a pair of 3 all going together. They're not lumping 1, 2, 3, 4, 5, and 6 together and then only grouping 7 and 8 together. That you have to break it up evenly. That's really it. So let's do this with, they give a good example later on talking about test grade. Oh, actually, they use a percentage of college students attending college in their home state. And they do a little less than chart. They also do a separate one with SATs. So let's try and take a look at both. Let's start off looking at just plain old test scores. Now, of course, this was a very good situation for a stem and leaf display, but that doesn't mean we can't use a regular frequency table to then make it into a histogram. So I'm gonna, kind of already jump to the construction part. I'm looking at test scores, but now I need each class to be clear. So I can't say I want my test scores to go to 50 to 60, 60 to 70, because if I want to make categories like that, it's pretty natural to try and group them in 10s like that. You can group them in 5s or 2s, but 10s are a pretty common way to, again, get the big picture. By the way, that's exactly what we are doing with the stem and leaf display, right? Every leaf that went with a stem of 5 represented a score in the 50s. But the problem with this is, where does somebody who gets a 60, where do they go? They need to have one place to go. So if you get exactly a 60, do you go here or do you go here? That's the problem with this setup. But with test scores, these are discrete data values, no fractions or decimals, so we can use an easy cutoff. We could say, no, let's not do it this way. Let's go 50 to 59, and then we'll go 60 to 69, and then 70 to 79, and now that solves the issue. And there's no ambiguity here. No one's getting a test score above a 59 and below a 60. Or at least not in any normal circumstance. Not many teachers give decimal points on test grades. I guess some do. But for most of us, it's a whole number test score. So this will cover everything. So with this type of setup, I can, so here are my test scores, and let me just finish this off. So we'll go 80 to 89, and then 90 to 99. And I'm just making up some frequency totals. So we had 2 people got this, 3 people here, 7 people here, 2 people here, and 1 person here. So there's my frequency table. Again, we could do relative frequency. I'm not worried about that right now. If you're going to make the appropriate histogram, well, you still have to label everything. And for this one, it's probably simple enough to just go test scores and over here frequency. Thinking about scale, only going up to 7, it's easy enough to just give a dash for every unit. If you went by 2s here, that wouldn't be terrible, but there's definitely no good reason to start making your scale going by like 5, 10, 15. That's, again, you make a scale so that it's useful, so that we could see what we need to, not that we get a smudged, ugly picture. But as far as the test scores are concerned, what the book likes to do here is to do this little clever, they'll do 49.5 to 59.5, and then make their bar based off of that. So they're extending it the extra 0.5 units so that all your test grades are actually covered. You get a 50, you're above a 49.5, you're in this category. You get, a 58, well, you're below 59.5, you're still in here. So similar here, in this type of situation, just by doing this plus minus 0.5, now on our scale, now it makes sense why the bars touch. I'm not just drawing this as a 49.5 to 59.5. I'm literally just labeling the x-axis. But by doing that extra 0.5, now all the whole number values fall in between these, so now that bar clearly represents this category. Next, would have this bar to represent this category, and then I have to get up to 7 here. And then we get 2 here, and then just 1 here at the end. And there's our histogram. Bars touch. That's the x-axis. Notice, again, I keep saying it because it's one of the most common mistakes. People take this, they go 50 to 59, and they draw an arrow. Then they go 60 to 69, and they draw an arrow. They just make their bars touch, but they're just basically making a regular bar graph and then just making the bars touch. The reason the bars touch in this type of situation is because they're going from one to the next. Okay. So that's the first one. Now, the second part is, now these data values made sense as discrete data values. But then the next thing, if you have something like they do the percentage, it certainly makes sense to have fractional or decimal percentages. Or I'm going to do one based on number of hours of sleep. Last night. A lot of people say I slept for 7 hours, I slept for 8, but you probably didn't sleep exactly 7 hours. You may have, but maybe you slept for 7 hours and 15 minutes or 8 hours and 2 minutes. Again, we naturally round it off, but there are fractional and decimal components. So I could still try and do something like this, but now, it's a little less common to go, you still can't go 6 to 7, 7 to 8. You still need to have that separation because you could have somebody who sleeps exactly 7 hours. So maybe 6 to less than 7, 7 to, and now I should really write. Instead of just putting a dash here, I should literally write 6 to less than 7, 7 to less than 8, 7 to less than 9. So anybody who slept more than 6 hours but less than 7 is here. Anybody who slept more than 7 but less than 8 is clearly here. So here's my hours of sleep. And then separately, frequency. So again, just make up a couple of numbers here. So let's put, we had 4 people here. We had 12 here. And oops, I'm sorry, this is 8 to less than 9. And we have 17 here. So now my histogram, labeling everything, hours of sleep, frequency. If we're going up to 17, that's my high total. How far should I go? Maybe I'll go by 5s this time. 5, 10, 15, 20. That can work. The bigger thing that I want to show you here is that now how do you deal with this? These nice whole numbers, we simply do the 0.5 on either side to make that bar clearly represent these whole number values in between these decimal values. But now over here, how do you do that less than 6, 7, 8, 9? All you do for this, draw your bar just short of the number. So 6 to less than 7 gives me 4. That is less than 7, right? I'm just to the left of the 7. That is less than 7. Now my next one, unlike here where this bar is literally touching, here it's almost like we draw a separate bar just past it. But by the thickness of my pen or pencil, it makes it look like it touches. But now I start drawing here directly above 7, 7 to less than 8, and now we're going to go up to 12 on this one. And last 8 to less than 9, now we're going up to 17. It's very, very subtle, everybody. That's the point I have to make. You could very easily look at the ones they do with sleep deficit and not even realize that's the point of what they're trying to do. But that is exactly it. That idea of a less than is just trying to stop this one bar just in front of this digit, and then the next one starts right on it. But by the thickness of your pen or pencil, it makes it look like they touch. Here's a tiny little gap. I'll just fill it in because they essentially touch, right? What is the space between a number just less than 7 and 7? And there really is no space, because what's less than 7 is just that tiny bit less. So that's the ideal way to set these histograms up, right? We want classes to be the same size, so that here we're getting every 10 units here. Here we're basically getting every hour of sleep. So that way when we look on the corresponding histogram, these bars are equal width. And the equal width from these bars makes sense because each of the classes are the same length. I'm going to pause this video, everybody. There's a siren that's been going off, so I want to wait for that to finish before we continue.